Yes, my dear students of 10th standard. Nowadays we are discussing about textbook evaluation of Unit 9 solution. Today we are going to discuss about Roman letter 6 long answers. The long answer, first question, write a short notes on saturated solution and unsaturated solution. First question, long answer, Roman letter 6 long answer. Question number 1. Write notes on saturated solution and unsaturated solution. So this question also already in your book itself there. The beginning of the lesson it is given what is saturated, what is unsaturated. So normally here it is given in page number 126. So 9.3.3 based on the amount of solid dissolved in the solvent, solutions are classified into three types. First one is saturated solution, second one unsaturated solution, and third supersaturated solution. Out of these three, first two things are asked for explanation in the first long answer. What is saturated, what is unsaturated? So saturated solution in which no more solid can be dissolved in a definite amount of the solvent at a given temperature. So a particular amount of solid only or can be dissolved in the definite amount of solvent. What is called definite amount of solvent? Usually we refer this definite amount for 100 gram of solvent or 100 ml of solvent. So how much of a salt or solid is dissolved in 100 gram or 100 ml of solvent is going to give saturated solution. For example, 36 gram of sodium chloride can be dissolved in 100 gram of water at normal 25-degree room temperature. So not more than 36 gram of sodium chloride can be dissolved in 100 ml of water at 25 degree at normal room temperature. So 36 gram of sodium chloride going to give a saturated solution. So you have to understand no more solid can be dissolved in a definite amount of solvent at the given temperature. No more. So the solution reaches its maximum solubility. The maximum solubility that is called the saturated solution. Then unsaturated solution, that is less amount of solid is dissolved compared to the saturated solution at the given temperature. Less amount of so you can add some more solid to get this saturated solution. So unsaturated solution is one that contain less solid than that of the saturated solution at a given temperature. Example, 10 gram of sodium chloride in 100 gram of water, or 20 gram of sodium chloride 100 gram of water, 30 gram of sodium chloride 100 gram of water at 25 degree. So actually 36 gram is the maximum amount of solid that can be dissolved in the given amount of solvent. But if it only 10 gram or 20 gram or 30 grams are dissolved, mean we can add some more salt. Suppose 30 gram of sodium chloride dissolved in 100 gram water, mean you can add further 6 gram of salt to get the saturated solution. So unsaturated solution means less amount of solid or less solid is dissolved in the definite amount of solvent. So only these two things are asked in the first long answer. Roman letter 6. Write notes on saturated solution and unsaturated solution. Then second question, write note on the factors affecting solubility. Write notes on the factors affecting solubility. That is in page number 128, 9.4.1. Factors affecting solubility. Actually, there are three main factors which govern the solubility of a solid. They are: first one, nature of the solid and solvent; second one, temperature; and third one, pressure. So the nature of solid and solvent, temperature and pressure, these are the three important factors which affect the solubility of a solvent. So what is the nature of the first one, the nature of the solid and solvent? The nature of the solid and solvent plays an important role in solubility. Although water dissolves an enormous variety of substances, both ionic and covalent, it does not dissolve everything. The phrase that scientists often use when predicting solubility is like dissolves like. This expression means that dissolving occurs when similarity exists between the solvent and the solid. For example, common salt is a polar compound and dissolves readily in polar solvents like water. Nonpolar compounds are soluble in nonpolar solvents. For example, fat dissolved in ether, but nonpolar compounds do not dissolve in polar solvent. Polar compounds do not dissolve in nonpolar solvent. So you have to understand clearly here. See, the fact is, the simple term is given, like dissolves like. What is the meaning of this phrase? Scientists often use this term, like dissolves like, mean polar solvent dissolve polar salt or polar solid. So polar compound readily dissolve in polar solvent. Sodium chloride, sugar, glucose, and these things are polar compounds and readily dissolve in polar solvents like water. So water is a polar solvent and it is also called a universal solvent. So water dissolve most of the things, ionic compounds and covalent compound, but it does not dissolve everything. But it does not dissolve everything. For example, fat and protein, these things cannot be dissolved in water. So nonpolar compounds are soluble in nonpolar salt. For example, fat, sulfur. So fat dissolved only ether. So the ether, benzene, toluene, acetone, and these are the non-polar solvents. Non-polar solvents. So fat cannot be dissolved by water. So fat dissolved in ether. So non-polar compounds do not dissolve in water. That is polar solvent. Similarly, polar compounds cannot be dissolved by non-polar solvent. Polar compounds like sodium chloride. Sodium chloride cannot be dissolved by non-polar solvents like ether. So you have to keep this term in your mind, that like dissolves like. Polar compound readily dissolved by polar solvent. Non-polar compounds readily dissolved by non-polar solvent. This is the first factor which affects the solubility of a solvent. Then second factor, effect of temperature. Solubility of solid in liquid. Generally, solubility of solid in liquid solvent increases with increase in temperature. So, solubility increases when temperature also increase. So, temperature increase, solubility increase. Temperature decrease, solubility also decrease. For example, a greater amount of sugar will dissolve in warm water than in cold water. So, when the water temperature is more than the room temperature, normal temperature, if it is a warm water, it can dissolve more amount of sugar compared to the cold water. Then, in endothermic process, what is called endothermic? Endothermic means it is the chemical reaction which involves the absorption of heat energy. So during that process, endothermic process, solubility increases with increase in temperature. At the same time, in exothermic process means what? A chemical reaction which involves the evolution of heat energy. So in exothermic reaction process, solubility decreases with increase in temperature. So endothermic, solubility increase of temperature, and exothermic, solubility decreases with increase in temperature. For example, solubility of gas in liquid. Do you know why is it bubbling when water is boiled? Solubility of gases in liquid decreases with increase in temperature. Generally, water contains dissolved oxygen. When water is boiled, the solubility of oxygen in water decreases, so oxygen escapes in the form of bubbles. So during the boiling of water for cooking, what happens? See, the dissolved oxygen escape. The dissolved oxygen escapes. So in exothermic process, solubility decreases with increase. So temperature increase, the dissolved oxygens are escape out. And also see, when temperature is when temperature is decreased, the solubility of oxygen increase. For example, the aquatic animals live more in cold region because more amount of dissolved oxygen is present in the water of cold region. This shows the solubility of oxygen in water is more at low temperature. So solubility increases solubility increases when temperature decrease so in the Arctic region, so what happens, see, the temperature is very low. So during that decreased rate of temperature, more oxygen is dissolved in water, so it is very feasible for the aquatic animals to live. So that's why see the aquatic animals live more in cold region compared to other places because of more amount of dissolved oxygen. So these are the two factors. First factor, the nature of the solid and solvent. Second one, the effect of temperature. Then third factor, effect of pressure. So effect of pressure is observed only in the case of solubility of gas. So we use this effect of pressure only for the solubility of gas in liquid. So when the pressure is increased, solubility of gas also increase. So pressure is directly proportional to the dissolution of gas. So increase of pressure, increase of solubility. The common example for solubility of gas and liquids are carbonated beverages. For example, that aerated water, soda water or carbonated water, that is in soft drink, household cleaners containing aqueous solution of ammonia, formalin aqueous solution or formaldehyde. See that carbonated beverages are prepared by applying pressure. When pressure is applied, the carbon dioxide gas is dissolved in water. Then also this is related to the Henry's law. See in the more it is given the effect of pressure and the solubility of gas in liquid is given by Henry's law. This question will be asked sometime in 2 mark. Define or what is called Henry's law. It states that solubility of gas in liquid is directly proportional to the pressure of the gas over the solution at a different temperature. So it is simply you can write that solubility of gas is directly proportional to the pressure of the gas. That means solubility increases when pressure increases. Solubility decreases when pressure decreases. So these are the three important factors which affect the solubility of a solid, that is nature of solid and solvent, temperature and pressure. Then next question, what happens when magnesium sulfate, in third detail, as you can see, the third detail, is what happens when magnesium sulfate with 7 moles of water is heated. Write the appropriate equation, define solubility. So normally see this water, the hydrated salts, magnesium sulfate, the 7 moles of water. When you're going to heat this salt, what happens? See, the 7 molecules of water is going to be removed. It's going to be escape. So the colorless, suppose the salt is colored, mean the colorless salt will be formed. When further, if you're going to add the water, again the salt, the magnesium sulfate going to retain the color. So here it is given in page number magnesium sulfate with 7 moles of water, page number 130. Magnesium sulfate heptahydrate. Magnesium sulfate heptahydrate formula MgSO4 with 7 moles of water, also called Epsom salt. Its water of crystallization is 7. So 7 moles of water is there. When magnesium sulfate heptahydrate crystals are heated gently, it loses 7 water molecule. So when the salt is heated, it loses its 7 water molecule and become anhydrous magnesium sulfate. Anhydrous means without the water molecule. So magnesium sulfate with the 7 moles of water, magnesium sulfate heptahydrate, on heating, the 7 moles of water is going to be lost. So anhydrous magnesium sulfate is formed. Anhydrous magnesium sulfate is formed. And one more question in this, define solubility. Define solubility. What is called solubility of a solvent? It is given in page number. It is in page number 128. It is given the first para. Solubility is defined as the number of grams of solid that can be dissolved in 100 gram of solvent to form saturated solution at a given temperature and pressure. At a given temperature and pressure. These first 4 lines are the definition. Solubility is defined as the number of grams of solid that can be dissolved in 100 gram of a solvent to form its saturated solution at a given temperature and pressure. For example, 36 gram of sodium chloride can be dissolved in 100 gram of water to get the saturated solution. So the solubility of sodium chloride is 36 gram. So solubility is nothing but the amount of solid that is required to get the saturated solution in 100 ml of water. 100 ml of water. Then next question, that is fourth question. It is given, differentiate hygroscopic substance from deliquescent substance. Differentiate hygroscopic substance from deliquescent substance. So here it is in page number hygroscopic, that page number 131. Hygroscopic substances and deliquescent substances, when exposed to the atmosphere at ordinary temperature, they absorb moisture, do not dissolve. So hygroscopic substance absorb moisture but do not dissolve in it. At the same time, deliquescent substance absorb moisture at ordinary temperature, but they dissolve in it. Then hygroscopic substance do not change its physical state on exposure to air. But here, deliquescent substance change its physical state. Hygroscopic substance may amorphize solid or liquid, but here deliquescent substances are solid. So first point, hygroscopic substance, they absorb moisture but do not dissolve. But deliquescent substance absorb moisture but dissolve in it. Hygroscopic substance do not change its physical state, but deliquescent substance change its physical state on exposure to air. And hygroscopic substance may be amorphous form, solid or liquid, but here deliquescent only in crystalline solid. So these are the 3 differences between hygroscopic and the deliquescent substance. So my dear students, you have to go through all these 4 detailed answers. First one, writes notes on saturated solution and unsaturated solution. Then what are the factors affecting solubility of a solvent? Then What happens when magnesium sulfate with the 7 moles of water is heated and solubility? Also the final fourth one, the differences between hygroscopic and deliquescence. So you revise all these four detailed answer, write in practice, and you will be given timetable for the half-yearly examination. And prepare well, don't waste the time. And the three lessons in chemistry, that is lesson 7, 9 and 11. 7, 9 and 11 are for the half-yearly examination in the chemistry portion. And you prepare well, get ready for the exam. Wish you all the best. God bless you. Thank you.